everyone, and welcome to the TDWI webinar program. I'm Andrew Miller, and I'll be your moderator. For today's program, we're going to talk about using a semantic layer to democratize the enterprise data lakehouse. And our sponsors today are Databricks and Stardog. For our presentations today, we'll hear first from James Kobielus with TDWI. And after James speaks, we'll be joined by Kian Shahab with Databricks and Naveen Sharma with Stardog. Before I turn over our time to our speakers, please allow me to go over a few basics with everybody. Today's webinar will be about an hour long, and at the end of their presentations, our speakers will host a question and answer period. If at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, please click on the Help area located below the slide window, and you'll receive technical assistance. If you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. And if you'd like a copy of today's presentation, use the Click Here for a PDF line there in the left middle of your console. In addition, we are recording today's event, and we'll be emailing you a link to an archived version, so you can view the presentation again later if you choose, or if you'd like to share it with a colleague. Again, today we're going to be discussing how to use the semantic layer to democratize the enterprise data lakehouse. And our first speaker today is James Kobielus, Senior Director of Research for Data Management at TDWI. Jim is a veteran thought leader, industry analyst, consultant, author, and speaker on analytics and data management. Over the past 3 decades, Jim has held analyst positions at Futurum Research, Wikibon, Forrester Research, Current Analysis, and the Burton Group. He also served as Senior Program Director with Product Marketing for Big Data Analytics for IBM, where he was both a subject matter expert and strategist on thought leadership and content marketing programs targeted at the data science community. At TDWI, Jim focuses on data management, which encompasses database platforms, data governance, data integration, master data management, and data ops pipelines, and more. Please welcome Jim, and with that, I'll hand it over to you now.
Thank you, Andrew. Hello, everybody. Hope you're having a good day. It's a pleasure to be speaking with you today. Yeah, it's using a semantic layer to democratize the enterprise data lakehouse. That's a fairly complex topic, and we'll unwrap it layer by layer. So really, the semantic layer, what is it? Well, of course, it's a layer that abstracts the semantics, the concepts of the data domains that are aggregated within a data lakehouse, and unifies them, makes them comprehensible to their intended users. So semantic layers are a fairly complex piece of infrastructure. We'll explain what that's all about, really. And so semantic layers are key lakehouse infrastructure. They enable greater unification of access and comprehensibility of all enterprise data assets within an open lakehouse architecture. What they do is semantic layers present a clearer understanding, really a standardized taxonomy and definitions of disparate data domains across the lakehouse's various areas, subject areas, domains. Semantic layers are an enabler for empowering data lakehouse users to access and to explore data and analyze it on a self-service basis. And the semantic layer is an enabler for accelerating the delivery of meaningful, actionable, data-driven insights throughout a high-performance lakehouse architecture, especially when it's the semantic layer is extended and embedded by contextual data quality rules and policies, so that the data is cleansed and conformed and so forth, contextualized. But also very much that it's standardized and harmonized around a common semantic layer. So the end users have a clear sense of what the data is about and have great confidence that the data is high quality, and so can use it for decision support and other business applications. So when we look at really expanding access to an enterprise data lakehouse, the whole notion of data democratization comes in. Democratization is about expanding not just access, but the actionability of the data and the analytics that are provided by, hosted by, and enabled by the lakehouse. And democratization is very much contingent upon having a semantic layer that can deliver a unified view, a more simple view, a clear view, more usability of the data, and really thereby accelerate the insights that are enabled through the Lakehouse. So I will unpeel this onion of the data lakehouse right away in terms of what are the key elements of a data lakehouse to enable greater actionability and democratization of the assets contained therein. And where does a semantic layer fit into all this? So when we look at the architectural principles for enterprise data, an effective and useful enterprise data lakehouse, they're really fourfold. They're, first of all, simplicity, unifying access to enterprise data. Really, all users, all business people, and others who are accessing the data lakehouse should enjoy unified access to the full range of assets across disparate data domains that they need to be productive. So within a lakehouse architecture, really a lakehouse fundamentally is an aggregation and a unification of both the data lake for unstructured data and semi-structured data, for data exploration and analysis, data science, and plus the data warehouse, the structured data that's used for business intelligence reporting and decision support. Of course, behind the scenes, there should be ideally a unified pipeline for both data ops, that's ETL and data cleansing and so data governance and so forth, plus ML ops, that's an enabler for greater automation of the machine learning workflow that transforms data enables the greater development and more improved and more accurate deployment of machine learning models based on the data. So simplicity is about unifying access to all these back-end data and analytics pipelines and domains. And what that depends on is both a unified view, a unified pipeline, a unified experience for accessing, analyzing, and manipulating and processing all that data, a unified management and monitoring and optimization of it all, and a unified abstraction layer for programming cloud-native data analytics microservices. So really what we're talking about is an open, for a lakehouse architecture should be open in terms of hardware, software, and cloud architecture, should be built on an open source software stack, and is enabled through open APIs, all of which is an enabler ultimately for simplicity in terms of accessing what behind the scenes can be and often is a fairly complex deep stack of data and analytics. So there's simplicity as a key design principle for data lakehouses. There's clarity. Clarity is all about presenting transparent cross-domain semantics. Users should be presented with a clear and consistent explanation of the data's meanings, connections, and context in the lakehouse. So you have the lakehouse, and the data should be consolidated, cleansed, current, conformed, comprehensible. In other words, the full set of data quality, data cleansing, master data management, and other data processes should be applied to the data and analytics assets as before they're loaded into and as they're managed within the lakehouse architecture. And that depends really on a clarity in terms of a unified cross-domain, standardized semantics enabled through data virtualization, a unified data model, things like a knowledge graph to connect the various data domains and relationships. Of course, mapping and mediation, transformation, a searchable data catalog, a key aspect in enabling greater clarity and visibility across disparate data assets. A business glossary, a key element of an overall semantic architecture, a standardized business glossary, presenting the data in the context of standardized definitions, taxonomies that are well understood and accepted by the end users of the data elements, as well as a robust metadata management capability. So clarity of access to data and to the meanings of the data across disparate domains. Usability. A data lakehouse to be effective needs to be usable, needs to empower users, enable greater self-service access to data and analytics. All users of a lakehouse should have the right tools they need to explore, analyze, model, and otherwise consume lakehouse data assets. So what we're talking about here is fundamentally semantic search is a key enabler for usability, be able to search by concepts as opposed to standard keyword searches. Query, a strong, of course, high-performance query optimization architecture. Visual data exploration is critically important for self-service. of course, reporting and knowledge graphs. Knowledge graph, as I said before, is a key enabler for access to and viewing of relationships among disparate data elements, to enable predictive analysis, machine learning, natural language processing, and embedded analytics in a way that's highly self-service, meaning the end user can use visual, concept-driven semantic search to enable access to all the back-end data and analytics assets. And really that the self-service analytics should provide access to and comprehensibility of the data for all data domains, be they finance data, marketing users, other lines of business. They should be able to view the data and work with it within the context of standard semantic definitions as enabled through a unified semantic layer. And acceleration, another key aspect of a strong data lakehouse architecture, is acceleration of insights, and really acceleration at the speed of thought. Users should be able to consume the data and the analytics in real time through a low latency lakehouse infrastructure. And really low latency can be any number of things. It's stream computing is often a key enabler, a no-copy data management architecture, so that the data is stored and managed only in one place, but is accessible to all analytics and downstream applications using a no-copy architecture that ensures that there's a minimum of copying of the data and transport of the data within the back-end data infrastructure. There's a way of speeding data access to the downstream applications. Query plan optimization, change data capture, in-memory, scalability and parallel processing, near real-time stateful computation, query predicate pushdown. These are key enablers, result caching for a low latency data lakehouse architecture. Such things as in-place federated query execution, also key elements. But really, what we're talking about here is, and all of these are key enablers for highly performant and unified data lakehouse architecture that delivers consistent, standardized, and comprehensible semantics of the data to all of the intended end users. So with that, I'm going to hand it back now to Andrew, who will, excuse me, I'll flip back to the next slide, pardon me. And Andrew will introduce the panel and my panelists as soon as I get it where it needs to be. Andrew, can you help me? Here we go. It keeps flipping past that one, but Andrew, take it away.
Terrific. Yeah, thank you very much, Jim. We got where we needed to go there.
Yeah.
Before I introduce our next speaker, just a quick reminder to our audience that if you do have a question, please enter it at any time in the Ask a Question window. We will be answering audience questions in the final portion of our program. This does bring me to our next speaker. His name is Kian Shahab with Databricks. Kian is an experienced data professional and solutions architect with Databricks, working with large financial services organizations. Kian has been a solutions architect at Databricks since 2020 and is passionate about enhancing the adoption of the data lakehouse architecture while helping to modernize the financial services industry with the most cutting-edge technologies. Welcome, Kian, and I will hand it over to you now. Jim, actually, Kian's going to do a little presentation before we jump into the panel, FYI.
Yes, yes.
Take it away, Kian.
Awesome. Thank you, Andrew, and thanks for a great introduction, Jim. So I'll just start by giving a quick overview here of Databricks as a company, and I'll jump into the data lakehouse architecture paradigm in just a minute. So for anybody who's not familiar, Databricks is an end-to-end data platform serving use cases and personas that range from data ingestion and data engineering to preparing data for downstream consumption, whether that be through machine learning and predictive analytics use cases, as well as historical analytics and data warehousing from a single source of truth. So just a little bit of background about Databricks. Databricks as a company has been around for about 10 years now. Many know of Databricks as the company that invented Spark, which is a distributed computational framework that really changed the game for big data and AI and enabled companies to get the most out of their data assets. So our founders created Spark and open sourced it through the Apache Foundation, and Spark today is still one of the most widely adopted open source frameworks. And for many years, we really helped companies of all sizes and industries scale their ETL and AI workloads and enabled enterprises adopt Spark by abstracting away the complexity of managing the underlying infrastructure and maintenance that comes along with that. But a few years ago, things really changed when Databricks was at the forefront of a paradigm shift towards this new architectural concept that we created called the data lakehouse. And as Jim mentioned some of this, but the premise of the data lakehouse is really to combine the best of both worlds when it comes to data warehouses and data lakes. Most organizations today struggle with data silos centered around having separate data lake and data warehouse architectures for different problems and different use cases, right? So many organizations will leverage data lakes for unstructured data and alternative data, streaming data, and machine learning use cases. And some organizations will land all of their data in a data lake. But then they will also need a separate data warehouse environment to serve their historical analytics and BI use cases, right? This can inherently result in data silos and multiple copies of data, multiple governance models, and also inconsistency across both environments, making it a little complex for the end users to really get value out of their data. So what we aim to do by creating the data lakehouse architecture was to create a single source of truth for all types of data at the data lake level and bring the ease of use, performance, reliability, and governance features of a data warehouse directly to the data lake. So today, Databricks is one of the largest private tech companies in the world, and we help all kinds of organizations across many different industries and verticals realize the potential of their data and democratize their data for different use cases and personas through this lakehouse-based architecture. So now let's talk a little bit more about what this lakehouse architecture actually looks like on Databricks. All right, so just starting at the bottom here of the chart on the left, for us at Databricks, this lakehouse vision really begins at the cloud provider level. So Databricks is a fully managed offering available on all three major cloud platforms. We partner very closely with the cloud providers in two major ways. So we leverage the cloud providers for a secure deployment in the customer's cloud account and for the underlying compute resources from their account. We also leverage the customer's cloud object storage and data lake to store assets as Databricks is not a data storage platform. So we sit on top of your data as a computational engine and an abstraction layer to make this data more usable and more performant at the data lake level. And at the core of the data lakehouse is really making all of that kinds of data very usable and reliable and performant by avoiding the typical data swamp that can typically arise in a traditional data lake, right? So the foundation of our data lakehouse is a fully open source storage format that Databricks created called Delta Lake, which helps us work with our data in the data lake as if it was in a data warehouse. But additionally, we get flexibility of using languages like Python and also unifying batch and streaming data, again, just in one single environment. So data is always in an open source format in the customer's storage accounts to avoid that vendor lock-in as well. As Jim mentioned, it's very important for this lakehouse-based architecture to be built on open source and open standards. And for us to really bring that data warehousing functionality to the data lake, we also enable additional fine-grained governance, bringing role-based and attribute-based access controls with a three-level namespace construct, a catalog, a schema, and tabular view directly to the data lake with governance at each level for groups and users. And lastly, we make this data usable outside of the data lake without having to move the data to a separate data warehouse for ad hoc queries. So with the data lakehouse, we can serve data directly to users in their favorite BI tools in a very performant and secure way. So with these key aspects serving as the foundation of our data lakehouse, we can now enable the end-to-end data supply chain and multiple users to get value out of their data from a single source of truth. The lakehouse also enables us to have a single environment for descriptive and predictive analytics, meaning we can perform our ETL style operations on all kinds of data and make this data usable for additional users for ML use cases and historical analytics. So that is a little bit about Databricks. Excited for our panel conversation in just a bit, but I will hand it back to Andrew.
Perfect. Thank you so much, Keon, for that great presentation. This actually brings me to our next speaker. I will be happy to be joined by Naveen Sharma with Stardog. Naveen is Vice President of Product at Stardog, a leading enterprise knowledge graph technology platform provider. He is a highly regarded data management expert and seasoned product management executive, and has helped organizations achieve significant growth with new production innovation and adoption. Among other positions, he has served as VP of Product at both Precisely and Pitney Bowes. Please welcome Naveen, and with that, I'll hand it over to you now.
Thanks, Andrew. Appreciate the introduction. I'll just jump right into the slides here. Oftentimes we talk about semantic layers, but the first question I almost always get is, how do you describe a semantic layer, right? And the best way to understand this, especially if you're new to the topic, is let's look at this from a lens that we all can perhaps understand. I put this slide together with the help of one of my colleagues. The idea here is, typically we think about data represented on the left as a set of tables with columns. You can see there's two tables there: a person ID, a full name, a gender, and another table that kind of describes that the royal family tree, right? So we're looking at the British royal family. Very topical given Prince Harry's recent book that got released, and a lot of controversies around that. The idea there with the second table is that you can start to see a parent-child relationship between each members within the royal family. Now, you look at those two sets of tables, one of the things you will see is not obvious. And go back here. I'm seeing some issues with the slide presentation. Is that true on your as well, Andrew?
Yes. Let me see here. 1 second.
Yeah.
Let's try this.
There
we go. You should be good to go now.
Yeah, one of the things you'll notice here that the data has only members and that parent-child information, right? But what you don't see are semantic terms that are referenced within that table structure. Things like brothers, sisters, siblings, aunts, uncles, etc. They just don't appear anywhere in the data. Now, we will look at it just purely from what's in the data. You'll start to see example of statements about the data, which is Queen Elizabeth has a child, Charles, and Harry has a child, Archie. That's what we can glean in terms of questions we can ask in the way the data is structured today. And the idea is that if we can create a semantic model and express the semantic model through annotated business rules without making changes to the underlying source data or the source data model, then we have a better position in terms of asking the types of questions we want to ask that go beyond how the data is described in the underlying data set itself. What that really means is now we can start to describe things in terms of domains. If a person has a child, then the person is a parent. A grandparent is the parent of a parent. The male sibling of a parent is the uncle of the child. So those are expressed in terms of semantic ontological statements. Essentially, it's an annotated set of business rules on top of the actual semantic model that's been described. And what you can then begin to see is you can start to ask more enriching questions of the underlying data without reshaping the data or the underlying source data model. So now I can ask the question and get the answer. Queen Elizabeth is the grandmother of Prince William. Harry is the uncle of Charlotte, right? So we take the statements from subject matter expert and express them in ways that can manipulate and express data into knowledge, i.e. that is semantically enriched data. Now this construct follows what has been in place through what Google's done for search for the last many years, right? So their knowledge graph essentially is what powers the entire World Wide Web. And so these standards that are based on W3C standards that are defined around semantic web as well. And so the implementation of this enables you to be more expressive in the ways you can ask questions of the data without having to reshape the underlying data itself. So let's get right into it. You can start to then ask the questions, right? Find the nephews of any aunts. Well, that's a very tough question given the original data set that we showed you. Now we can actually express that as a set of business rules that are annotated on top of the model itself, where you can get the answers you seek. And these rules and this logic can be specific to a given business function a business analyst within a functional domain area, and again, not requiring you to reshape data to answer the questions you're looking for. So to really bring out the idea of what a semantic layer is, I thought it'd be good to just start with that example. And so representation of this sort of in the more real world context is enabling a flexible data layer for answering complex queries across a diverse set of connected enterprise data. Now you can imagine that diverse set of enterprise data construct against, as what James mentioned, could be unstructured, could be structured, could be semi-structured. Ultimately, the goal of the knowledge graph powered semantic layer is to harmonize your data, metadata, and rules based on business meaning that is abstracted away from the underlying storage. So you can leave data where it is. You can leave data in the lakehouse where it lives, but you can create and define a model that is specific to the context of the use case by harmonizing things based on business meaning and annotating it with your business logic, with your data quality constraints, or data access policies that you want to define. You also have the ability to limit data sprawl, right? So what that really means is you're not making copies of this data. You're leaving data at source, and you're federating access to that data at query time across those heterogeneous source environments. So if the data lives in the lakehouse, we do the translation and get you the data that sits in Delta tables in the lakehouse. And ultimately with the goal of what? Ultimately with the goal of enabling this notion of the data democratization to citizen data users so that they can self-serve in context. So the idea of federated data access and federated governance, because those rules, the logic, the constraints, the access policies can be defined by functional areas within the enterprise. And you can do that without having to reshape, as I said, the data at the underlying source itself. And so when we look at it, in terms of how this sits on top of a lakehouse architecture like Databricks, essentially our ability to work with data, across the curated data environment, as Keon mentioned, from this notion of raw data that sits in this bronze layer in Databricks Lakehouse, to silver layer, where it's a little more filtered, cleansed, or augmented, to the gold layer itself. Our ability to connect through the SQL warehouse endpoint of Databricks, so we can actually virtualize access into the lakehouse. We can also decide that we want to bring data in that needs to be cached, and we can leverage the power of Spark. That's another way for us to be able to pull data in and materialize that within the Stardog environment. And then again, the end goal of what? The end goal of being able to both define a semantic model, and that could be based on the metadata that's captured within the Unity data catalog. So our integration there allows you to take a bottom-up approach by being able to take what's been defined within Unity and use that as the basis of your first initial semantic model. Or you want to push this information out from Stardog, the enterprise knowledge graph platform, into running more large-scale graph analytics. We can leverage the power of Databricks Spark for that purposes, or we can push data frames directly using our Python API within your notebooks on Databricks as well. So lots of flexibility that's built on top of this lakehouse architecture. Of course, the end goal is what? Our end goal is really to support use cases, and use cases vary by industry. Ultimately, many industries have connected data needs, like healthcare, life sciences for drug discovery, like manufacturing for building out a digital twin and thread or bill of materials, like financial services for operational risk, across the entire organizational data landscape, financial crime specifically, customer 360. Lots of different use cases have needs for data to come together in ways that align semantically, whether to serve the need of a very specific use case within a functional area of the organization, or to look at it more holistically and put together an enterprise data fabric architecture, which can be built on top of the lakehouse as well. So lots of different use cases here. And again, as I mentioned, the goal here is really to push this into your consuming application. Yes, we have our own interfaces from which you can interact. As James talked about, our knowledge graph platform will allow for visual exploration. The data can be embedded in your own applications that's custom built through our GraphQL, REST APIs, or through our SQL endpoint into your preferred BI tool of choice, or through Python data frames directly within Databricks or other Jupyter type of notebooks. And for those that are new to the idea of a semantic layer or are interested in learning more about enterprise knowledge graphs, we certainly recommend there's opportunity for you to get started for free. Go check us out. If you are Databricks users, we are part of their Partner Connect program. So we have direct connectivity from your Databricks workspace. If you follow that thread from Partner Connect, you can actually look for the semantic layer category, and Stardog is one of the vendors that has pre-built integrations within your workspace, so we can automatically consume all of the Databricks workspace information and kind of get you jump-started on that journey as well. So with that, Andrew, I'll turn this back to you, and excited to get into the panel discussion next.
Terrific. Yeah, thank you so much, Naveen. Really appreciate that great presentation there. I just wanted to address something quickly for the audience members. We did have an error in uploading the link for the PDF, which is how you can access these slides, but I wanted to assure you that that link has been fixed. If you can please refresh your browser, you should be able to access it now. If for whatever reason that still does not work, we will be emailing a link out with a recorded version of this particular webinar, as well as a copy of these slides. So apologies for that. Now I will ask that both Jim and Keon rejoin us for the panel discussion. And Jim, I'll hand it over to you now.
Thank you, Andrew, and thank you both Keon and Naveen for those great discussions. So really what I'm going to do for the next 20, 25 minutes is ask each of you on some level to summarize some of the key points that you made, but elaborate upon them. So let's just start, from square one. What is a semantic layer? I've given a definition. Each of you has discussed it, but can each of you describe in 25 words or less what is a semantic layer? Keon, I'll start with you.
Sure. Yeah, I'll give it a shot, Jim. So in my mind, a semantic layer really acts as kind of like a layer of abstraction between the underlying data and the data sources and the end user, who oftentimes could be a business user who might be a couple steps removed from the underlying data. It can also help kind of the end users interact with data in ways that they're familiar with without having to understand the underlying data structure or the query language associated with the database that the data resides in. And then really there's oftentimes kind of like business logic that needs to be incorporated into the semantic layer to help those end users make sense of that underlying data.
Right, good. So Naveen, what's your definition of a semantic layer? What do you want to add to what Keon said?
Yeah, look, Keon expressed it exactly the way I think about the notion of a semantic layer. For those that have come from the industry in data warehousing BI space, the semantic layer idea of a semantic layer is not new, right? A lot of BI products had introduced this idea in the early days. I think the way I kind of think about it, just very simply, it's the idea of knowledge representation of your corporate data assets, right, in ways that is consumable by a broad representative of users inside that enterprise. So think about representing how we represent data within the data platforms of today, like Databricks. They're represented as strings, and so the idea that we can represent data as things or business concepts that have relationships between those concepts that are more meaningful to the business in order for them to accelerate their understanding and decision making, right? That's really the power and the definition of what a semantic layer enables.
Yeah, that's very good. Yeah, I'm sorry, go ahead.
Now, I was just going to say the pun about not being your grandfather's semantic layer is also what kind of highlighting a little bit more what Keon said is a semantic layer is not just an abstracted data model with better business definitions, but it also has the ability to represent business logic within that data model. It has the ability to represent constraints that are specific to your specific use case, and like I said, within your own functional department. and the ability to express things in terms of data access policies, what data specifically someone can or cannot have access to. And then more importantly, it allows you to tie your metadata and your data layer all together in terms of a query answering system, right? And that's the beauty as well.
Very good. I think you hit the nail on the head with consumable. Its semantic layer enables a greater degree of consumability by the intended users because it's close to the business. It delivers the data or presents it or contextualizes it in a way that enables greater actionability of that data. So that's great. So we'll move on to the next. How can a semantic layer then accelerate democratization, or in other words, really improve access to, or enable improved and broadened access to your enterprise data lakehouse? How can it be a key enabler in your attempt as a business to unlock the value of your data and analytics assets to a greater degree by enabling more users to do more things with the data? So either one of you can step in and respond to this one.
Yeah, I'm happy to take the first one since Kian took the hit on the previous question first. And it really, look, at the end of the day, that's the sole purpose. I almost describe semantic layers as the last mile in data democratization. I think the Lakehouse architecture has been really widely accepted now as a critical infrastructure, as a data platform architecture to push broader democratization of enterprise data. And I kind of look at semantic layers that's like closing the last mile, with the idea there that by representing all the data as concepts that are more meaningful to the users, number one, you get users engaged in the process of both engaging with the data in terms of policy definition, model creation, governance around what constraints to define against that data itself. So you get more participation by the actual consumers. And then more importantly, the semantic layer essentially enables this notion of self-service. So yes, the Lakehouse is absolutely powerful, especially when you're doing lots of data processing, building machine learning models, even down to the Lakehouse architecture, enabling reporting from a traditional warehouse perspective. But where the semantic layer really helps is the ability to bring more users that are self-described citizen data users to participate in this process, right? Because now they're asking questions of the data based on those business concepts, that business meaning. You looked at the idea that I just described with the royal family. I can ask questions of the data regardless of how that data is represented underneath, right? So I can ask uncles and aunts and nephews, even though I only have a children relationship between two members.
Right. Really, it's all about data transparency. The meanings of the data are transparent so that the end user can access that data, and as you said, in a manner that is self-service. They don't need to ask a data architect to explain the data to them. It's self-explanatory. So Kian, what are your thoughts on this question?
Yeah, I mean, I think Naveen really nailed it. Also, I love the royal family analogy. I think it really helps, put a fun twist on this, and also helps it make sense. In my opinion, what I see lots of large organizations struggling with is getting value out of their data in an efficient way. And lots of times this has to do with a couple different reasons. One could be that the data that the business users need is in multiple siloed environments, and it's hard for them to access that data. The other one is really that it's hard for them to understand the data relationships and how to make sense of that data that their organization has. In the case of the Lakehouse, I think the first challenge is kind of naturally resolved to some degree, because you'll have kind of one single source of truth for the vast majority of your data. But I'm a solutions architect for financial services. Lots of data is still on-prem due to regulatory or security reasons or others. That semantic layer can really help the business users make sense of what data is available for them in the Lakehouse and what data is available outside of the Lakehouse. Also, the notion of self-service I really love that, and I believe that. So as data practitioners, we really can't be there to answer every single question for the business users. We want to empower those users to get their own answers to the questions that they're looking for, right?
Right. In many ways, the semantic layer is, you're talking about really silo convergence. The semantic layer is really the last mile in silo convergence as an enabler for a very powerful lakehouse architecture to deliver actual value to end users. Right. I'm going to move on to the next one in the interest of time. How can enterprises leverage a semantic layer? How does it really work? How does a semantic layer enable greater harmonization of data models with standard, well-understood concepts and vocabularies? So what's really going on under the covers in a semantic layer? So whoever wants to step in first and answer this, go ahead.
Yeah, I mean, look, I'm happy to take a shot at this first as well. So you think about the representation of the underlying data model. It's basically a business ontology, a business information model, right? A logical data model, as you would in the construct of a structured data warehouse. You talk about logical models and conceptual models and logical models, and then you talk about physical data models. This is that sort of conceptual data model that is represented as a business ontology. And the beauty is that it's sort of independent of any underlying data storage infrastructure, right? So the representation of that business ontology is based on open Web3 C standards. You have many industries that are looking to define ways to create a common business ontology or vocabulary for very complex domains and problems. So you look at pharma life sciences, especially in the drug discovery, drug industry. That's a big, huge area. There's a lot of information exchange that happens both internally within the organization, but also a lot of data exchange that happens externally. This makes for a common, well-understood semantic model or ontology, a business information model that allows for easy information exchange, in terms of open data standards. This has been a huge benefit for lots of those organizations. Financial services, as Kian mentioned, where he comes from, they've defined this called financial instrument business ontology, FIBO, for those that come from that domain. Again, another way for a lot of this financial services industry clients to start to think about harmonization, so that when the 2008 crash happened, and Lord forbid it doesn't happen again, there is a way for them to all understand data in the same way, from a regulatory perspective, from regulators when they ask the questions, to internal compliance officers and the compliance teams when they ask the questions. So everyone's looking at information in much the same way. So that representation of that business ontology essentially is a schema that is independent and supports this notion of almost like a multi-schema, multi-tenancy type operation, right? Because you can now have different ontologies describe different parts of the functional domains inside the enterprise, but then it can also be brought together as one large cohesive business ontology if you wanted to go across and ask questions that way.
I'm glad you brought business ontologies into this discussion. So I'm going to ask Kian, what are your thoughts? How really, when looking at the overall semantic layer, how does it actually work to enable greater harmonization around really canonical or standardized ontologies and vocabularies?
Yeah, absolutely. I mean, I think it's a great question, Jim. As much as we would like for it to, data doesn't come with a user manual out of the box, right? So we have to help our business colleagues and even other data practitioners and other areas of the business make sense of that data by applying the business logic and the terminology that's maybe company specific to that underlying data within the semantic layer, right? And each organization is going to have their own nuances, their own terminology, their own data dictionaries, right? I can't even begin to tell you, the types of organizations that I work with and how many three-letter acronyms they have and how many, unique identifiers they have for their data, right? And that data is always going to be intertwined and connected in many different ways. And I think Naveen really nailed one thing that he mentioned too was, if you want to add on some of this, logic essentially on the fly, right, without having to alter the underlying data, that's especially where I think the semantic layer could be useful. Again, I'm, in a world without maybe a lakehouse being kind of the center of the ecosystem where we have, data from all different types of underlying databases, operational and analytical databases flowing into the lakehouse. In a world without that, right, there's going to be data all over the place. There's going to be, different column names that mean really the same thing. And usually I think a semantic layer is a really helpful way of really kind of like dissecting that data and making it make sense.
Right, adding business logic on the fly for new uses. So move to the next question. Knowledge graphs fit into this overall stack, and you've both discussed this. Really, knowledge graphs, where do they fit in the overall semantic layer? Are they an essential component of every semantic layer that an enterprise should develop, or are they for specific requirements related to more flexible ad hoc viewing of semantic relationships?
Yeah, I mean, look, my take, perhaps a little biased on this topic, is that
Right.
Knowledge graph serves as that foundation of enabling a semantic layer. And the reason why you want a knowledge graph powered or enabled semantic layer is because you want the ability to address both the simple ideas and concepts within the organization. Perhaps you're only serving the needs of a BI organization. They're trying to standardize on KPIs and metrics, and that's great. But you have the ability to then take this notion and extend and expand that to lots of different use cases, enable lots of different use cases in terms of almost answering different questions by different departments, some ad hoc, some more urgent and critical to the needs of the business, some that are more holistic across the organization. And this is a great way for you to kind of number one, based on open industry standards, and number two, the simplicity by which it integrates both with the underlying data storage, and in the case of the Lakehouse, our integration there, it can certainly expand beyond that. As Kian mentioned, a lot of the data lives on-prem at times or in other cloud environments. We have 150 types of connectivity options available there, and our ability to then enable that with business logic that can be added on top of that. It can also be added on top of you can create your own data quality constraints. But the bigger idea there is that lots of those industry use cases start to get complex because there's a requirement of bringing a lot of that domain knowledge and that connected data knowledge to answer very complex questions, right? So this has the capability to start small and start simple and can quickly expand to address more complex needs of the business.
Okay. Kian, care to add anything to what Naveen said, or can I move on?
Yeah, I mean, I'll just mention one quick thing. I think when we actually start thinking about use cases that lots of organizations are, attempting to solve for, things like even customer 360, it's hard to essentially draw a dotted line to, from a customer to so many different relationships that they have. Using something like a knowledge graph can really help to unlock those relationships that maybe whether it be the data practitioner didn't realize that it was there, maybe it's not obvious, maybe the business user didn't know it was there. So I think something like a knowledge graph can really help get to this level of insight much more quickly. And ultimately, if the goal is for customer 360, get a better understanding of your customer, offer them better products or cross-sell opportunities or whatever it might be, something like a knowledge graph is really at the core of that.
Great, yeah, knowledge graphs are essential for connected data domains. So when we look at knowledge graphs, we have to consider graph databases as a key piece of the overall data platform architecture. So let me ask you both. What is the role of a graph database in support of a knowledge graph, or really in support of a robust semantic layer in your Lakehouse? And how can a graph database enable presentation of these connections in a way that is ACID compliant for transactional applications that might need to rely on this data?
Yeah, look, I'm happy to take this one as well, Kian, first. Again, the two things I want to make the distinction is, number one, the Stardog Enterprise Knowledge Graph platform has a storage layer. There's the bigger benefit that organizations see with our technology is the ability, or our platform is the ability to leave data in place, right? So you don't have to actually materialize data out of the Lakehouse, out of Databricks, and put that into a graph database inside of Stardog. That's number one. Number two, what's underpinning our storage layer is fully ACID compliant. We do have many organizations that want consistency of rights and ACID compliance, and so partly because they will want some architecture that has a hybrid implementation where they may want to leave some data in place. They may want to materialize some data inside of the knowledge graph storage layer. And more importantly, we support the ability of caching data when it makes sense, especially when it comes to addressing more read-heavy latency types of requirements. So there's a lot of flexibility. The idea of a graph database as a requirement is not something that we enforce, and it's really driven by the idea of what ultimately is being driven from a use case perspective. We subscribe to the idea that we want to limit as much data sprawl as possible, that a lot of data needs to be brought together sort of that during the compute time and can be left in place, right? So being able to virtually access that information and federate that data access is a key component of what we deliver.
Kian, your thoughts?
I really think Naveen nailed this one. The only kind of shameless plug I'll give here for the ACID compliance part is really ACID compliance is, a critical part of the Lakehouse architecture as well. Without having that ACID compliance, there is really no Lakehouse. Traditionally, data lakes lack that kind of ACID compliance guarantees. So having that reliability and the performance, if you have, a partial, you have a commit and it partially writes or gives you inconsistent results, these are the types of things that result in a data swamp, right? So just wanted to say, out of the box, this is something that the Lakehouse helps resolve in tandem with something like a graph database.
Great. And then last but not least, before we move to the audience Q&A, talk about data quality in this context. How can business vocabularies as surfaced and materialized or presented, I should say, through, say, a semantic layer embedded by a knowledge graph, how can business vocabularies be improved and enhanced through application of contextual data quality rules within the semantic layer? So where does data quality fit into this overall architecture?
Yeah, and I look, again, based on the open semantic web standards, one of the benefits of a platform like ours is the ability to not only create this semantic model construct, but create and define data quality constraints. So, if you're trying to pull in cars, and cars have, association to wheels as parts, then a constraint is that, you can't have let's say cars only have to have 4 wheels. You can define a constraint that the car has to have 4 wheels, in order for the data quality rule to be validated against the data that's being pulled in based on that constraint that's been defined against that data model. So the idea you talked about, contextual data quality rule, it's important to emphasize that can be set of data quality constraints that are sort of as part of the federated data governance you can have by different departments, different functional areas within the organization. They are annotated against the semantic model and then don't require reshaping the data in any way, right? So, and that's the benefit of a knowledge graph powered semantic layer, is the fact that you can create those and define those constraints against that semantic model.
And Kian, any thoughts before we move to audience Q&A?
Yeah, I mean, for me, this all kind of points back to, again, self-service analytics, right? So the easier we make the underlying data to be leveraged downstream by, whoever it might be, business users, for example, the better our lives are as a data practitioner, right? And having consistency across these data assets is extremely important as well. There's going to be, differing versions of, different columns and things like that, and we're going to have to apply the business vernacular to it to make it really usable by those downstream users, right? So I think, a key metric for a kind of like a data practitioner, a data engineer, for example, should be how widely usable is your data by that end user.
Great. Andrew, I'm going to hand it back to you. We have some great questions coming in from the audience. I want to thank my panelists, and I'll hand it back to you, Andrew.
Terrific. Yeah, thank you all for that great discussion. We'll jump right into the audience Q&A here. First question will be for you, Keon, and this might be something you touched on, but perhaps you can expand a bit. So Keon, what kinds of use cases and personas does a data lakehouse help enable?
Yeah, it's a great question, Andrew. I mean, at a use case level, there's lots in financial services that we mentioned a few already, things like customer 360, fraud detection, these types of things. But I think really it's important to think about the data lakehouse as an underlying data platform that can serve many different downstream use cases and unlock value for many different personas as well. Traditionally, with kind of a disjointed data lake and data warehouse architecture, you have different personas, meaning you have data engineers and machine learning engineers and data scientists working with data in a data lake, and you have kind of BI analysts and more front-end analysts working with data in a data warehouse. With the data lakehouse, this is all kind of unified. We serve many different personas, including the ones I mentioned, from a single source of truth in one environment.
Yeah, and I would just add to that, it's same with respect to the Stardog platform, the ability to serve personas that are more business analysts, perhaps data scientists that want to operate within their own notebooks, or BI reporters that want to use the semantic layer and ingest that inside of their BI tool of choice. We kind of represent ourselves as a SQL endpoint to a BI layer, so you can consume it much the same way.
Terrific. We'll move on to the next question here. Naveen, this one's for you. What skill sets are needed to work with Stardog's semantic layer?
Yeah, I mean, look, more importantly, given our origins from the whole semantic web standards, we've really started to see data modelers, who sort of come from this understanding of modeling paradigm, have started to be a major persona for us. Data engineer / data scientist. So they're, again, the ability for them to create both models and mappings, right? So much like they've done traditionally with ETL tools, they're able to do that through user interfaces that are built on top of the Stardog platform. And so that skill set is something that can be easily leveraged, and certainly developers have access to APIs, and so if they want to integrate that within their own applications, or SQL BI writers want to embed that within their own preferred BI tool of choice, we're looking to enable the organizations to leverage the skill sets they have internally within the organization as much as possible.
Moving over to Keon for this next one, similar question. Keon, what kind of skills would a practitioner need to use Databricks and leverage a lakehouse architecture?
Yeah, we really strive to be kind of like an open architecture and platform where, within those personas that I mentioned a second ago, if you're a data engineer and you're, used to working with Python or SQL, there's a place for you with Databricks and in general with the data lakehouse architecture. It's really meant to kind of empower those practitioners and end users as well. So if you're a machine learning engineer or data scientist, and you want to use your own open source libraries and frameworks, Python-based or R-based, for example, you can use that within Databricks. There's a very nice notebook environment that's collaborative, where you can essentially multi-language supported. You can flip back and forth between code that's based in Python or SQL. And then really, there's a whole different experience for more of a SQL analyst, right? If you're a great SQL user and you want to use Databricks UI with a SQL workbench style for your use cases, you can certainly do that. Or, best of all, if you want to use data from your Lakehouse served into a BI tool like Tableau or Power BI, for example, or to a tool like Stardog, you can certainly do that without even having to really know that Databricks is powering that under the hood.
Fantastic. I think we'll have one more question here. We'll squeeze it in. Naveen, back to you for this one.
Okay.
What are some tips or best practices to enable business units to adopt usage of the semantic layer? Due to the push for self-service BI, several business units are content with using the ODS layer or have upskilled as pseudo data engineers and are reluctant to let go.
Yeah, look, best practices, again, is you kind of ease into it, right? So you first of all give them tools that they have that provide capabilities that their current tools don't, right? So the idea of data exploration against connected data and presenting that as concepts that are easy to follow is an important aspect of enabling something for more of those types of business units and business users. But more importantly, letting them kind of consume the knowledge graph or the semantic layer directly inside of tools of their choice, their BI tools. So Tableau, Power BI, and they want to operate within that construct. Our ability to push that through our SQL endpoint directly within those tools enables them to kind of work against the semantic layer as if it's just another SQL layer for the purposes of creating reports or dashboards.
Terrific. Well, I know that there was a lot of questions. Thank you all to the audience members for asking those. We'll try to get those out to these speakers and they can get addressed offline here. But this does unfortunately bring us to the end of our time today, so allow me to thank our speakers. We did hear from James Kobielus with TDWI, Kian Shahab with Databricks, and Naveen Sharma with Stardog. Also, please allow me to thank Databricks and Stardog for sponsoring today's webinar. And remember that we did record today's webinar, and we'll be emailing you a link to an archived version of the presentation, which you can feel free to share with colleagues. Finally, I'd like to remind you that TDWI offers a wealth of information, including the latest research reports and webinars about BI, data warehousing, and a host of related topics. So I encourage you to tap into that expertise at tdwi.org. Lastly, from all of us here, let me say thank you very much for attending. This does conclude today's event.